Hi everyone, Scott with CyberScribe.org, and in this video I'm going to walk you through some of these diagrams I did on routing fundamentals. So think of this as a high-level overview. It's not going to teach you the the dirty details of the stuff. Like you can see this little simplified packet. I don't have anything about the CRC, the check sequence in the back. I don't have anything about destination ports, source ports, SYN and ACK and stuff, and flags and types on all these things. But this is just to give you a basic idea of how stuff gets from a source to a destination. So we're just going to walk through some of these diagrams and talk about them as we go. So here, this top one, you see how it's color-coded network A, B, C, D, and E? Well, the reason why it's a different network, if you think about it, is that these all have different network addresses. Okay, so this one might have, the yellow might have 192.168 dot dot something. This orange might have 172.16 dot dot, and this one might have 10.0.0.0/8 or /30. Okay, so the point with the network A and network B and C, what makes them different? Different network addresses. Okay, if this guy, yellow, and the orange had the same network address, they would be just one network. All right, so that's one thing to think about is when you're routing, when it goes, you're talking about going from network to network, crossing those networks, and then actually getting to a destination. So let's go to the next one and show you how that is done. So as you can see here, color coded again, and the network, local area network here, like you see, I say it's a layer 2 domain. Well, why is that? Because traffic within this network uses a MAC address to communicate. Example, 10.0.0.1, the computer wants to talk to the server. Okay, if it doesn't know the address of that server, it knows the IP address, but if it doesn't know the MAC address, that's, you see here, layer 2 MAC address, that's the first thing that's looked at. Okay, so on a local network, MAC addresses are what's being used to pass it across the network like that. So in this case, 10.0.0.1 wants to send out to the server there. If it doesn't know the address, it sends out an ARP request first, and then the ARP, I'm not going to go through all the ARP stuff, but you should know that address resolution protocol right there is how you resolve the IP address to the MAC address. Okay, so it would send out an ARP, and the ARP would say, well, who has the MAC address for 10.0.0.10, and then tell 10.0.0.1. If you do Wireshark and you could do capture, you can see that's pretty much what the packet says for ARP. It says, like I said, who has 10.0.0.10, tell 10.0.0.1. So a Wireshark is good to look at for this kind of stuff, but like I said, high-level overview. Layer 3 domain, well, what if I want to get to a different network, all right? Well, the thing is, it's going to do the same thing with an ARP, but this computer, because it's going to look at the IP address of the packet that it's sending out, and it's going to first ask, is it in my local area network? This one was, and then since it was, it said, okay, well, ARP. We're going to just ARP to this guy, and that's how we're going to get the address. We're going to just ARP, get the MAC address, slap it on there, and then send it to the guy. Doesn't even go to the router in this case, all right? But if it needs to go to a different network address, this is going to know that, and that's the reason why you have to put in your default gateway every time that you set up an IP address, because if it's not in this local network, it sends out the information to the default gateway. What if it doesn't have the default gateway's MAC address? It does an ARP. Okay, so what happens then is this would send, okay, let's look at this packet right here. Keep in mind, layer 3 addresses, TCP, UDP, and the data never changes when it's crossing a network. Never will change when you're going from point A to point B across the internet anywhere. What will change? Layer 2 MAC addresses. At every juncture between networks, the MAC addresses are going to change, source and destination. Okay, so let's say this guy, he sends it over here to the router there, and the router gets it. He's going to look at this packet and he's going to say, okay, is it sent to me? And then the MAC address is going to be obviously for him, so he's going to say yes. He strips off the packet, the frame header right there. That's frames and packets and stuff. Is kind of used interchangeably, so people can get picky, but right now we're not going to. He strips off this frame header and he looks at the IP address, and then he says, is it in my local network? And in this case it is. You see, it's right there. We're going to that guy. So in that case, what he does is he sends it directly to that guy if he knows the MAC address. If he doesn't know the MAC address, he sends an ARP request, and then this guy gets back saying, yes, 172.16.0.10's MAC address is ... Right? And then he goes and sends it to him. So keep in mind, as traffic passes along in between networks, this one, this top one here, let me just show you. Okay, if this packet, if this big frame is sent from the source to the destination, this layer 3 TCP UDP header and the data will never change. The IP addresses do not change. What will change at every layer, as it passes across from network to network, the layer 2 MAC addresses will change. Okay, so here you send it here, this source and destination MAC address, he's going to change it and send it to this guy. Okay, then he's going to strip it off and he's going to change it, send it to this guy, and then he's going to, see what I mean? See how that goes? This, it's like it just gets taken off and put back on as it crosses networks. That's the layer 2 MAC addresses. Okay, so like I said, high level overview here, and that's, we can talk for hours about this stuff, but really this is just like a 10-minute video or so. So watch it again, but the more you practice with it, the easier it'll be, the more it'll make sense to you and things like that. Okay, so let's just go through the simple routing diagram. All right, and so we have this computer here, and we're going to send it to the server here. It's crossing this one network in the middle there. Okay, and the traffic is going to be going between routers there, and the routers are the ones who strip off that frame header and add new frame headers. Okay, a switch doesn't do anything. A switch, remember, is a layer 2 device, so that's just going to like record the MAC address and say where it, what port it came in on. Okay, and see, like I said, layer 2 is MAC address, layer 3 is IP address. So let's go and let's start here. So let's just take this packet, all right, and we're going to say this is starting at this computer. Okay, so this one is going to build the layer 2 source packet, layer 3 source destination packet. So what it's going to do, let's say it knows the MAC address of this router. Okay, what it's going to do is the layer 2 MAC address, the source, is going to be this computer. The destination is going to be this router, you see. But the layer 3 source is going to be the IP address of this, but the layer 3 destination is going to be this one, the server, the end destination. Okay, so you see how it doesn't change. The layer 3 source and the layer 3 destination will not change. Okay, the layer 2 source, the MAC addresses, will change. Okay, so this guy gets the packet. He strips off the frame header with the MAC addresses because it's addressed to him after all, and he looks on his network and he says, okay, well, I'm going to 192.168. Is that on my network? No, it's not. Well, do I have a way to get to that network? Well, yes, I do. How can I get to that network? Well, I send it to this router. So what does he do? He adds his layer 2 address as the source MAC address, and he puts the next hop router's destination MAC address as the destination MAC address. Keep in mind, layer 3 IP addresses never change. Okay, the layer 2 MAC addresses will change. So that's the trickiest thing in this part. Okay, so he gets it. He puts the layer 2 source and layer 2 destination in the frame header and sends it to this router. Okay, this router then gets the packet, strips off this layer 2 MAC addresses. All right, and he says, okay, well, this was sent to me because he's the destination MAC address. So what do I do? Is it in my network? Yes, it is. Okay, do I know, because that's the layer 3 destination, they strip off the layer 2 frame headers and they look at the IP addresses. Okay, and then they see, is this in my network? Can I get there? Do I have a route to this or no? So that's why they're stripping off the MAC addresses there. So there he goes and he says, yes, I know this computer is in my network. If it's not in his ARP cache, if he doesn't know the MAC address, he sends out an ARP request, Address Resolution Protocol. This guy gets back, he says, my MAC address is this. Then this guy, he's the layer 2 source, and he puts the server, the destination, as the layer 2 destination. And that's the final thing. So where the layer 2 and layer 3 destinations match up, okay, that's where the final traffic is going to be. That's where the endpoint is. So just keep in mind, it's gonna, your layer 2 source and destination, okay, your layer 2 headers are going to change. All right, your layer 3 IP addresses in your packet, it's going to be the same on the network. They do not change this. Okay, but that's why I said layer 2, the local host, the local domain is a layer 2 domain, because that's the one where MAC addresses are being used to push that traffic forward to the router or to the server, in this case up here. Okay, so it's a little complicated, and like I said, this was just meant as a high-level overview, just to kind of give you, let's say, reinforce what you already know, or maybe give you an idea of what it's all about, and then continuing forth. So don't think this is like an end in of itself. Most of this stuff isn't, but just be aware. So that is all I wanted to show you for this video, and stay tuned for future videos.